Now we'll take a few examples on condition for concurrency. This is a very trivial question. Prove that the given lines are concurrent. We have to show that these three lines are concurrent. So what we should do? We should solve any two equations simultaneously and get the point of intersection, and then if that point of intersection satisfies the third equation, then the lines are concurrent, otherwise the lines are not concurrent. So let's start by taking these two equations. You can take any two equations of your choice. 5x plus 3y is equal to 7, and if we multiply this by 5, we have 5x plus 10y equals to 0. We subtract this, we get minus 7y is equal to 7, y comes out to be minus 1. We put this value of y in any of the equations, therefore x 2 into 1 is 0, therefore x comes out to be 2. Therefore the point of intersection of these two lines is 2 comma minus 1. Assuming this to be, let's say, line 1, this is line 2, and this is line 3. Therefore L1 and L2 intersect at this point. Point of intersection of L1 and L2 is this. Now if this point satisfies L3, then the lines are concurrent. So let's see. 3 into 2 minus 5 into minus 1 minus 11. This is 6 plus 5 minus 11. What do we get? We are getting 0. Therefore these points or coordinates are satisfying the third equation. Therefore, yes, the lines are concurrent. We can also solve these by using determinant. Once you study determinant in class 12, you can solve through that method, and that is quite easy. For example, what is a1, b1, c1, a2, b2, c2? We have to make sure that we keep all the terms on one side. Therefore a1 is 3, b1 minus 5, c1 minus 11. Similarly 5, 3, minus 7, and 1, 2, 0. If the value of this determinant is 0, then we can simply say that the lines are concurrent. So what we do, we don't do anything, and we simply expand through R3. So what do we get? 1, and we'll get rid of this line. Minus 5 into minus 7 minus minus 11 into 3. Then plus, or rather minus 2, and we'll remove this row and this column. We'll have 3 into minus 7 minus 5 into minus 11. So this is 35 plus 33, and this is twice minus 21 plus 11 5s are 55. So this is 68 minus 2 into, this comes out to be 34. Therefore 68 minus 68 is what? 0. Therefore the lines are concurrent. Now determinant you will study in class 12th. Basically you will study determinant in class 12th, but once you study determinant, you can easily prove that the lines are concurrent or not. Let's take the next question. For what value of lambda are the three lines concurrent? Now in this case we have to find lambda so that the three lines are concurrent. We'll follow the same process. We'll take any two equations, solve them simultaneously, and put the value in the third equation, because it is said that they are concurrent. Therefore the point of intersection should satisfy the third equation. So let's take these two equations. We multiply this equation by 2. Therefore this is 2x minus 4y equals to minus 2, and this is 2x minus 5y equals to minus 3. We'll subtract this. What do we get? This goes, this is y equals to 1, and putting this value in any of the equations, x minus 2 into 1 plus 1 is 0, x minus 2 plus 1 is 0, therefore x comes out to be 1. Therefore the point of intersection of the lines is 1 comma 1. Intersection of, let's say this is line L1, this is line L2, and let's say this is line L3. Therefore this is the point of intersection of line L1 and L2. Now since the lines are concurrent, therefore this point should satisfy L3. 1 comma 1 satisfies L3. Therefore we'll put these values. 5 into 1, 9 into 1 plus lambda should be 0. 5 minus 9 plus lambda should be what? 0. Therefore lambda comes out to be what? 4. Therefore lambda is 4. That is, if we keep lambda as 4, these three lines will become concurrent.